Welcome. In this video, I'm going to demonstrate how to find the second derivative of x to the fourth plus y to the fourth equals 16 using implicit differentiation. So first things first, before we can find the second derivative, we need the first derivative. So let's find the derivative of this with respect to x. The derivative of x to the fourth with respect to x, well, that's 4x cubed plus, and now the derivative of y to the fourth is 4y cubed. And as we're treating y as a function of x, we need to multiply by y prime. And the derivative of 16 is 0. So 4y cubed y prime is equal to negative 4x cubed. Then y prime is equal to 4x cubed negative divided by 4y cubed. So the first derivative is simply negative x cubed over y cubed. All right, now that that's done, I'm going to scooch this over. You can leave it wherever it is on your paper, but this is not the main event. I want to have the second derivative here. Now I want y double prime, so I'm going to use implicit differentiation and apply the quotient rule to negative x cubed over y cubed. So we look at the derivative of the numerator first. That's negative 3x squared times the denominator y cubed minus the numerator of negative x cubed times the derivative of the denominator, which is 3y squared. And of course, since we're treating y as a function of x, we multiply by y prime here. Then divide by y cubed squared, the square of the denominator. So y double prime is equal to negative 3x squared y cubed plus 3x cubed y squared. And now, instead of writing down y prime here, I'm going to notice that y prime is equal to negative x cubed over y cubed. There. Notice how all I did here was replace a y prime with what we found as our first derivative already. And then, of course, we're going to divide by y to the 6th. So y double prime is equal to negative 3x squared y cubed minus 3x to the 6th power. That's for both of these x cubes, divided by y, and this entire quantity divided by y to the 6th. So in order to clean this up a little bit, that is simplify, I want to make sure I combine the numerator by multiplying this one that is not a fraction, this part, by the same denominator, which happens to be y. So I'm going to multiply by y over y to get y double prime is equal to negative 3x squared y to the 4th minus 3x to the 6th divided by y, then this entire quantity divided by y to the 6th. Now that I'm running a little low on space, I'm going to move my work over here. So y double prime is equal to, and what do we have in common here? We have a negative 3 and a negative 3, so I will factor that out. And I also can take out x squared from both of these. So negative 3x squared y to the 4th divided by negative 3x squared, all that's left is y to the 4th. And negative 3x to the 6th power divided by negative 3x squared, all that's left is positive x to the 4th. And then this is over y times 1 over y to the 6th power. So y double prime is equal to negative 3x squared. In our denominator, we now have y to the 7th power. And then notice I haven't done anything here yet. That's because, well, y to the 4th plus x to the 4th is the same thing as x to the 4th plus y to the 4th, and we know that's equal to 16. So y double prime is equal to negative 48 x squared over y to the 7th power. Hopefully this video has helped you understand implicit differentiation a little bit better and given you some insight into the little algebra tricks needed to fully simplify these implicit derivatives.